So here we have the integral from 0 to a, where a is greater than 0, of f of x over f of x plus f of a minus x. And we're supposed to just find the value of this. As you can see, it probably plays around with some sort of symmetry. And that's exactly what it is. So when you have a function that has some sort of symmetry, then I'm telling you, King's rule is going to help you. So here's King's rule right here. We have the integral from a to b of f of x, and that's going to equal to the integral from a to b of f of a plus b minus x. Now, a lot of people always want to see a proof about this, so we're going to go ahead and use u substitution, where u is going to equal to this value on the inside. We find our differential, which is going to be a negative dx, and you're going to notice that your parameters change. So when x is equal to a, u is equal to b, x is equal to b, u is equal to a. So they sort of flip right here. Now, what is that going to become? Well, this particular integral right here is now going to become this one, where you have the integral from b to a of f of u times negative du. Now, because we have a negative, if we bring it on the outside, we can flip these now. So we have a and b, and then that negative will turn into a positive, giving us this integral right here. Now, u is just a variable, so we can just rewrite it as integral from a to b of f of x. That's King's rule, and that's exactly what we're going to do with this particular integral. So if we follow the idea of King's rule, this is going to tell us that this integral, that one that we have right here, is going to equal to the integral from 0 to a of f of 0 plus a minus x all over f of 0 plus a minus x plus f of, and then don't forget this already has an a, so it's a minus 0 plus a minus x, and all with respect to x. Okay, so let's go ahead and start simplifying this thing. So on the top, we still have integral from 0 to a. This is going to just be a minus x, so we have f of a minus x over, and then this just turns into f of a minus x. And now check out what it's going to happen to this function. We're going to have negative a, or a minus a. So that's going to cancel out, and then this negative will distribute to this, giving us a positive x. So this is just f of x with respect to x. So we have two integrals, this one and this one, that are equal to each other. So we're going to go ahead and add them up. So the best way to visualize this, and whenever you do King's rule, I typically, or should have written I equals to this integral right here for safety reasons. Why? Because this is I and then this is I. Therefore, I can say 2i is equal to the original integral plus the second integral. But what's really nice about this is that they have the same common denominator. So we have the same common denominators. So we're gonna add this plus this. Hey, that's literally the same thing as the denominator. So you really just have one with respect to x, and now we just integrate. 2i is equal to this right here would just become x from 0 to a. So 2i is equal to a, so we divide by 2. The original integral I is going to equal to a over 2, whatever value that might be.